Good evening, sir.
Good evening,
Yeah,
sir.
good evening, Srishta. Good evening, everyone.
Good evening, sir.
Yeah, good evening. So, see, we have done two chapters. Now, I will like to continue or add something extra to the chapter 4. Okay. So, I will add something extra to the chapter 4. That means if there is something which is not in NCRT, but it may be required for the competitive exams. Okay. So it's necessary for the competitors, all of you who are preparing for it, or even if you're not preparing, so those concepts will be very useful over there. So I'm just going to add something extra in the chapter 4. Okay. So let's continue with chapter 4. Yes. So see what we are going to do. I've already informed all of you. So let's see in the chapter 4, what other things I'm going to discuss about. So other things we see in your chapter, we had discussed about the contact forces. All of you remember? We had discussed about the contact forces. Yes, everyone remembers we had discussed about the contact forces.
Yes, sir.
Yes. So the forces that act,
Hello, sir. Sir, actually, sir, out, sir.
yeah, hi.
Yes, sir. Actually, when I submitted my paper, sir, only one had paper went. So when I checked it, sir, I got full marks on that paper itself. And I talked to Manisha ma'am. She said she'll get my other papers evaluated as well, sir.
Okay. So I think you are the only you sent just one paper, right?
Yeah, sir. I did not know. I actually sent all three, sir. Something went wrong when going through.
See, always it's a good thing. You don't upload the JPG file. Okay, don't just
Okay,
directly
sir.
upload the pic. You first convert that into PDF or make a PDF and then upload it.
Okay, sir. I'll make sure from next time
Yeah.
without any
So
problem.
once you upload the PDF, then your whole file is uploaded. If you take JPG, so just one file may be uploaded. And yeah, still someone was there who had uploaded all the JPG files.
Okay, sir.
So there are chances. Okay, take care from next time. Okay.
Yes, sir. And Manisha ma'am said it may not be changed in the Wise app, but she said she'll change it in the main records.
Okay. Okay. So see, here contact forces we are discussing. The contact forces are the forces that act only when there is a physical contact between, only when there is a physical contact, only when there is a physical contact between the object, between the objects, okay, and whatever the forces are applied. So I gave you one of the examples. Can anyone give me the example for the contact force?
Sir, ball moving.
Which one?
Sir, weightlifting, sir.
No, I've talked. See, forces. Which force is a contact force?
Muscular force.
Muscular
Frictional force.
force. Okay.
Sir, I told
Muscular
weightlifting, no, sir. Weightlifting.
weightlifting. You are using your muscular force, right?
Yes, sir. Frictional force. Sir, what is the chapter called, sir?
See, this is the we are extending the chapter force.
Okay, sir. Thank you.
We are extending it. That means whatever is in NCRT, we are just moving it a little bit ahead of it.
Okay, sir.
Okay. So the muscular force. Any other examples?
Sir, frictional force.
Frictional force. Very good. Any other example?
No, sir.
No. Okay. So see, I'll discuss two other forces here. These are the forces of tension, okay, and reaction force, which we also call as the normal reaction. Reaction force or the normal reaction. So this is not in your NCERT. It's an extra part that I'm taking. So tension force, it acts in an object like a rope. Okay. So a rope, a spring, over there we have the tension force. So tension force is also a type of contact force. Suppose two people are, or suppose here you have a support, and from this support I tie a rope over here. Okay. So when I tie a rope over here, so the rope is lagging. Okay. When the rope is lagging, it means that here the tension in the rope is zero. There is no tension in the rope. Okay. The tension force is due to the electromagnetic forces of attraction between the molecules or the particles of the rope. Then when I start pulling the rope, when I pull the rope, so therefore force of tension increases. So when I start when I pull the same rope, now the rope becomes tight. So why does the rope become tight? Due to the tension force. When I apply a force F over here, a tension force is developed in this rope, and the tension force, it always applies towards the point of suspension. That means from wherever the body is hanging or from wherever it is attached. So tension force, it acts in the direction, it acts in the direction towards the point of suspension. Got it? So this is the force of tension. The other force is the reaction force. Yeah, what happened? Pranav? Yeah, Pranav, what happened?
Sir, can you once again explain the tension force?
Okay, see the tension force, this force is due to the forces of attraction between the particles of a rope or in a string. So first of all, this tension force, it is developed in a rope in a string. Tension force, where does it act? It is developed in a rope or string. So if you attach any object with a rope or a string, you try to pull it. So you are applying your force through the rope or through the string. So the rope becomes tight. Initially, the rope may be slaggy. When you apply a force on it, it becomes tight.
Sir, for example, pulling means the bucket from the well.
Yeah, when you pull a bucket from a well, or you can see, suppose if you whirl a stone in a circle like this, you take a stone and you tie it with a rope and whirl it in a circle. So here, see, has anyone tried this whirling a stone in a circle or whirling a ball in a circle? Tie a stone or a ball or anything with a string and try to whirl in a circle. Okay. So if it is tight, okay, if the string is tight, you can make it go round and round. And if the string is loose, you will not be able to make it go round and round.
Sir, like a compass, sir.
Like
A compass, sir.
not compass, just like this. See, I show you an example. Just let me show you the diagram, the pic I can show. Stone moving in a circle. So see, like this, the way this boy is making this go round and round. Okay. So here, when the boy is making it go round and round, the stone will go round and round only when there is no slackening in the rope. Okay. If there is any slackening in the rope, so then obviously it will, right?
Sir, this type of tool was used in wars, no, sir, in olden times, sir.
No, this is not watch. Okay. A watch is a
Not
different
watch, sir.
mechanism. A watch is a
Not
different
watch,
mechanism.
sir. Not watch, sir. Like in wars, sir. Wars.
Yeah, in wars. Okay. In wars,
They
it
use
can be used. Okay. So generally students play with these things also. Got it? So here, I hope everyone has understood about the string.
Yes,
Yes,
sir.
sir.
Okay, another way you can think of, suppose you have here two vehicles, and one of the vehicle is, you have here two vehicles. One of the vehicle is being pulled by another vehicle. So you have another vehicle and they are being pulled by this. Okay, so there it has been tied with a rope. So the first vehicle will keep on pulling the second vehicle till the rope is tight. If the rope is becomes slackens up, that means the tension in the rope is zero, and hence this will not be able to pull it. Understood the force of tension?
Yes, sir.
Yes.
Okay. The next is the reaction force. And before going to the reaction force, I'll just tell you an idea of the Newton's third law of motion. Okay. The reaction force is also a contact force. See, the force developed in the rope was the tension force, and it is a type of contact force. Okay. The next one is the normal reaction or the reaction force. I just call it as reaction force, which we also call as normal reaction. So this is also a contact force. See, for this we just need to understand a little bit about the Newton's third law of motion. Okay. So Newton's third law of motion, you will study the first law and second law later. The Newton's third law of motion, it states that for every action, there is equal and opposite reaction. Okay. So that means, it simply means that if you are pushing something, so that object is also pushing you back. If you are pulling something, so that object is also pulling you back. Okay. So this means for every action, there is equal and opposite reaction. We
Sir,
can
for
observe this in a number of activities. Okay, just 1 minute, let me finish it. So suppose here in water, you have a boat and you try to jump out of a boat. Okay. So when you jump out of this boat, suppose you start jumping from the edge, you jump out from the boat from here. So when you jump out, does the boat move in the backward direction? Does the boat move in the backward direction or not?
yes, sir.
Yes. So while the boat moves in the backward direction, you move in the forward direction. So if we understand this mechanism, During this mechanism, I am pushing the boat in the backward direction and the boat is pushing me in the forward direction. Understood this? So I applied a force of action on the boat and the boat provided a reaction force to me. Got it? So both of them showed the displacement, both of us showed the movement. Another activity we can try it out. Suppose here you have a wall and let's say you are wearing roller skates over here. You stand on these roller skates. So you stand on these roller skates over here and now you push this wall. Okay. So what will happen? If you are pushing this wall, will the wall also push?
Yes, sir.
Yes, sir.
Got it? So will the wall push you back or not?
Yes, sir.
Yes,
It
sir.
will.
it was.
Yes, wall will push you back. Okay, so we can say first I pushed the wall, then wall pushed me. So for every action we have equal and opposite reaction. Got it? Still, you can even suppose if you are here on let's say you are if you are not a roller skates and just I am using roller skates to understand that there will be minimum friction. Okay, just to reduce friction. So I think everyone has understood that for every action there will be an equal and opposite reaction.
Yes, sir.
Yes, sir.
Yes. So we'll try to make this with another example. Let's see. So here I take uh, suppose here on a table. Now let's take a table over here and on the table I have a book lying. So once you understand the normal reaction, it's a very important force to understand the normal reaction. So see, I keep a substance on the table, any object. I kept here an object on the table. Okay. So which force is acting on this object?
Frictional force.
Sir, gravitational force.
Gravitational force. Okay. So there is gravitational force that is acting on this object in the downward direction. So why it's not moving downward?
Sir, because there will be gravitational force even for the table, sir.
Yeah. Pardon?
Sir, because there will be gravitational force even for the table, sir.
So the table should also move down. Why the table is not moving down?
Sir, because table is already on the floor, sir.
So it should be going more down. Hmm? Okay, see, a very good try to you. Yes. So here, obviously, the ball is attracted by the gravity in the downward direction, and it
So
tends
can
to
I tell,
go.
sir?
Yeah.
Can I tell, sir? I know the answer.
Yes.
So the answer is contact force, sir. The contact force is the force which acts when the gravitational force is there towards the earth, but it's the force which is pushing back the item, sir. This is why items don't sink into the earth.
Okay. So very good. See what is happening here. The ball is trying to go downward. A force is acting on the ball. It's going to move downward. But the table is opposing its motion. So I can say that the ball is applying the force of gravity on the table. Okay. As a result, the table is applying a reaction force on this ball, and this reaction force I call as the normal reaction. So there are two forces acting on this ball. One of the force that act on this ball is the force of gravity, The other force that act on this ball is the reaction force. Okay, and since both the forces are equal, so the net force acting on the ball is 0, and hence the ball is not moving. Got it?
Yes, sir.
Okay. So see, these were the new concepts with the forces. Now I will also give you a little bit of idea from acceleration. Okay, a little bit of idea from acceleration and Newton's second law. Okay. Okay, Pranama, what was your doubt? Yeah, very good. So Pranava, we talked of string, we didn't talk of air, we didn't talk of water. Okay. So there is, of course, there is a tension in air also. There is a tension in air column. There is a tension in water also. Okay. Right. But why we don't consider, as they are the open systems. Okay. They are not confined systems. They are the open systems. Okay. Whereas rope is a confined system. It doesn't change its shape. It's confined. That's the reason. Okay. Anyone having any other doubt? Yeah. Pranav, are you speaking something? I think you are muted. You are not audible, Pranav. You are speaking up. You are not audible.
Sir, can you hear me now?
Yeah. Now you are audible.
Sir, does Newton's third law apply in small particles such as neutrons and protons, sir?
Yeah. It applies everywhere. Okay. Yeah. But when you reach relativity, okay. So for the relativity conditions, there are conditions where it becomes null and void. Okay. There are certain cases where we can't apply the Newton's third law under the relativistic conditions.
Relativistic conditions means what, sir?
Relativistic conditions means when an object is moving with a very high speed. That's the speed comparable to the speed of light. So under those conditions only we have the Newton's third law may not be applicable.
What happens if an object travels in the speed of light, sir? Why does it doesn't apply?
Yeah, there are different things that you can't understand right now. Okay. So if you try to get it, there are a lot of factors that happen over there. Okay. So that are beyond the scope of explanation right now. But yes, you can understand that the Newton's third law will not hold over there for the relativistic conditions. Okay, so we have done about these two. Now a little bit idea about the Newton's second law of motion. Okay. Then so Newton gave us the three laws of motion. I'll just give you. See, I told you in the beginning only. I'm extending the chapter force. Okay, so this is nowhere in NCERT. This is an extra thing added to the chapter force. And as I had promised that I will be giving you extra from every chapter. Okay, so this is the extra part of that force that we are providing here. So we also have here.
Sir, I have a
Yeah, what's your doubt?
sir. Actual unit for calorific value is joule, sir.
Calorific value is measured as joule per kilogram.
Okay, sir.
Newton's first law and second law. See, Newton's first law, it defines force. It provides the definition for force. So according to the Newton's first law, we observe what is force. It defines balanced and unbalanced forces, right? So these are the different things which are defined by the Newton's law. Pranav, are you speaking something? Pranav, you are not audible. Okay, see. So what is force?
Sir, a force is a push or a pull applied on any object, sir.
It's push or pull applied on any object. Okay. So this is the define of force that's given by the Newton's first law of motion, and it states that force is an interaction between two bodies. So I'm giving you another a good quality definition for force. So you can also tell this that a force is an interaction between two bodies that tends to change state of motion of an object. Okay. So what is force? It's something. A force is, it is an interaction between two bodies which tries to bring about any change in the state of motion. So also we'll talk of here about Aristotle. Okay. How many of you have heard about Aristotle?
Sir, I just heard that he's a mathematician, sir.
Yeah.
I just heard that he's a mathematician.
Okay. See, Aristotle is not a mathematician. He was a philosopher. Okay. So he was a philosopher, and who thought about the things. He presented the ideas about sciences. Okay. So about the thinking, he thought of all the things around us moving, how they move, what are the different ideas behind them. So he gave an idea that all it's the tendency of an object. So according to Aristotle, he observed the everyday object and he said it is the tendency of objects to come to rest. That means all the objects, they have a tendency or they want to be in the state of rest. They don't want to continue moving. Okay, just give me 1 minute. I'm coming back. Okay, let's continue now. So according to Aristotle, all objects, they have a tendency to come to rest. That means it was just like he observed the things. Suppose if you throw a ball, so the ball comes to a rest. Okay. Suppose you start cycling, and once you stop pedaling the cycle, so the cycle comes to the rest. Okay. So this was his observation, and from these observations, he concluded that all objects, they have a tendency to come in the state of rest. But it was later studied by a few scientists like Galileo and Newton, who proved it to be false. Okay. So they proved that it's not necessary, or all objects, they do not have a tendency to come in the state of rest. Because they have a tendency to remain in their state, in whatever state they are. Okay, anyone having any doubts from whatever things we studied today?
No, sir.
No, sir.
Okay. So see, this was the Newton's first law of motion. It gives us an idea, it gives the definition of the force, it gives us an idea what will be there if there is no force. Okay. So if there is no force, the object will continue to remain in its state. If it's stationary, it will remain stationary. And if it's moving, so it will.
Also, if there is no force, even we won't be able to move.
Yeah, what happened?
I have a doubt. If the force is not there, then even we won't be able to move.
No, it's not. We won't be able to change anything. Okay. To change anything, to bring about a change in the state of motion, okay, you have a force. Got it? Okay, so by all of you, I will just continue with the next topic in the next class.
Okay, sir.
Bye.
Thank you.
Okay, bye.
Bye, sir.
Bye.
Thank you, sir. Bye, sir.
Yeah, bye.
Sir, I know, sir,
Mhm.
I researched the reason, sir, for that.
Yeah, what's the reason?
Like if the object, like if the any object wants to travel at the speed of light, it needs infinite energy to move on with the same acceleration, sir.
Yeah,
So Newton's third law can't apply below the speed of light.
yes. Okay.
So here comes the topic of relativity, sir. That's why. And photons in light does not have a particular mass, sir.
Yeah. So on photons, obviously it doesn't apply. It will be applicable for neutrons and protons, but it not applicable for photons.
So actually Newton said that if any object has a mass, he said that the principle works, sir. So
Yeah.
these photons have a doesn't have a particular mass. So the Newton's third law won't be applied, sir.
Yeah, the Newton's third law is not applicable for photons. I think you asked for neutrons and protons.
Yes, sir.
Yeah, so for neutrons and protons, yes. Okay, for electrons also, but not for these.
Sir.
Not for, okay, bye.